Ladies and gentlemen, welcome to the encounter where we bring you face to face with the most inspiring leaders of our times. When you're with Netflix, you're pioneering the initial work of moving to the public cloud.
Yeah, we were trailblazing a little bit. We'd been thinking about cloud before that. I had some experience.
You're almost the harbinger of the cloud at Netflix, almost the industry level.
And we need to generate all the different bit rates and quality control them and all those things. At one point, I remember, how many machines can we get? So we just said, let's ask for 4,000 machines in one API call, basically. We just set an autoscaler to 4,000. Again, this is cool, it works, right? That was the kind of thing that was, for us, making it really work. Netflix needed to scale very rapidly. Or we depend on somebody else and focus our investments on content and product.
Now, why is sustainability important for the industry and why is it often overlooked?
And there's a couple of reasons for that.
And what is the industry in general doing about sustainability?
What are you doing? Well, I'm working for a company that's destroying the world is not a good answer.
So today I'm honored to host Adrian Cockcroft, one of the pioneers in cloud architectures. His experience spans Netflix, Battery Ventures, and AWS. Before retiring, his most recent role at AWS as a vice president was leading the sustainability efforts. Adrian is well known in the cloud ecosystem and the community for his leadership and contribution. Adrian, welcome to the encounter. We are incredibly excited to host you today.
Well, thank you. Thanks for the opportunity, and it's good to see you again.
Great. So, Adrian, I first came across your work when you were with Netflix and you're almost pioneering the initial work of moving to the public cloud. Uh, so, you're almost the harbinger of the cloud at Netflix and almost at the industry level. So, please share your experience of using cloud in its infancy when it was still very, very new.
Yeah, we were trailblazing a little bit. We'd been thinking about cloud before that. I had some experience. I was at Sun Microsystems before, and there were some early attempts to do things that you would now call cloud that we couldn't figure out how to kind of get to market. The early days with AWS, it was really a bet we placed because Netflix needed to scale very rapidly. And we said we either build out our own data center footprint very, very aggressively, or we depend on somebody else and focus our investments on content and product. And then we decided to try, let's see if we can make this work. So we did a few test runs pretty much in 2009. We moved some things that were not customer facing to the cloud. Like one of the first things we stood up there was actually a Hadoop cluster for processing the logs of streaming information. Like what's going on with the customers, how is all the logging, how is the streaming performance, what's the quality of service and things like that. And the other thing was movie encoding. We used to get the big high quality files from the movie studios for streaming. And we need to generate all the different bit rates and quality control them and all those things. And that was also moved to the cloud. So that was okay. At one point, I remember somebody saying, well, how many machines can we get? So we just said, let's ask for 4,000 machines in one API call, basically. We just set an autoscaler to 4,000 and just watched machines appear and went, oh, this is cool, it works, right? So just think about going to an operations person saying, can I have 4,000 machines for a few hours? And they'd say no, right? But all that was the kind of thing that was, for us, making it really work. And then in 2010, we decided, well, this was when streaming was growing very rapidly for us as a workload. And we did not have capacity in the data center to get where we thought we would be by the end of 2010. So we made the explicit decision we have to get out of the data center this year. certainly the front end, not the back end databases, but primarily the front end. And we just set a goal. Okay, we're not going to build a data center. We know we're going to be out of capacity later this year, so we have to go do it. So it was kind of a forced run. But on the AWS side, we were using pretty primitive AWS capabilities, and we had to invent quite a few things ourselves around them that nowadays would just come with the cloud. So we were using a handful of services. We had to do our own security modeling, our own sort of network management. There was no, VPNs and VPCs and no VPCs. There was no uh, key management, things like that. So we had to go build a bunch of tooling ourselves, and it was all the EC2 Classic, if people remember that. So the nice simple version, simple days. But it proved that it worked, and then we went out, and it was important to Netflix that we weren't the only people that ever did this. So part of the reason why you see, there are a couple of different reasons, but one of the reasons why you see, lots of talks from Netflix, we want other people need to do this too, so that AWS doesn't see this as one weird customer and a whole bunch of other people, right? We want to become a normal customer for the cloud and have other people use the cloud similar ways we work. We didn't want to be like the analogy I have is you want to be a small fish in a big pond in the cloud for both the statistical averaging of your impact, the workload, but also for the investment in the services. You want to have lots of customers that look roughly the same. And you want to be a small fish in a big pond. You don't want to be a shark in a paddling pool, right? If you consume like 60% of all of one service and everyone else is the other 40%, then there's a problem, right? Every time you try and do something, it breaks. So we were trying to help everyone else join us, and we got a lot of take up from startups and from what are generally called the scaled digital native companies, right? The Pinterest and people like that. They're digital native, but they're at scale, and that's sort of the category I'd put Netflix in. And then the enterprises were going, "You guys are just crazy. You'll be back in your data center eventually, whatever." So there was definitely the first few years it was all the scale digital natives and the startups, and then later on some of the enterprises went, "Hang on a minute, we need to do this too because we're getting left behind." That was kind of what the early days were like.
Amazing. 2010, 4,000 EC2 instances. And this was a time when there was not even EBS present in AWS, right?
I think we had EC2, we had EBS, we did have EBS, but there was only one kind of EBS, and you could only put so much stuff on it. The instance types were the M1, M1 small, M1 these tiny machines. There was no SSD, everything was spinning disks. We were trying to figure out how to get IOPS. It was very difficult to get any IOPS. You couldn't get much throughput on EBS. So very different to today. We ended up jointly developing a whole series of features of AWS by basically saying, this is what's needed. This is the things we need to push. And AWS kept rebuilding what they had to scale, and also building new services from us and others to build it out. So it was a very strong partnership between Netflix and AWS, and with other suppliers too. You may have heard of Nginx. Netflix was really the
Right.
first customer for Nginx. We were one of the first customers for App Dynamics for a while. It was bought by Cisco later on, but for monitoring. Eventually outgrew that one. And Cassandra with DataStax, Artifactory with JFrog. So there were a number. It was a conscious policy Netflix had to create a set of features that we needed by working very closely with the startups and the companies that could provide those features for us. That gets you sort of favored customer status, which is quite useful. You get a nice big discount, but you get to debug the thing you're trying to use, right? So, and you have to be it's a conscious thing. If you end up with a very low cost of operation and a very well tailored product that does what you want it to do at the scale you need it to run at. So, but most people don't have the I don't know. It's probably too risky for most CIOs to kind of take that role.
No, you literally influenced the roadmap of AWS. A lot of products, a lot of services came out of Netflix early adoption of EC2 and rest of the services. So, Adrian, your team actually built a set of tools and almost their own tool chain like Asgard and Kiosk Monkey. But one thing that actually stood out is Kiosk Monkey. And even today, I know a lot of customers do kiosk engineering and they model their deployments around Kiosk Monkey, the whole simian army that you went about building. So please share the backstory about of building Kiosk Monkey back then.
Yeah, I think there's two ways of looking at it. One was that the early days of EC2, the instances and the way they were being run, they weren't greatly reliable. Like machines could just disappear. Like if AWS needed to upgrade a rack of machines because there was a lot more downtime during upgrades, they'd just take a rack offline and your machines would disappear, or there would be a failure of some kind. They've got Nowadays the uptime of an individual instance is just very, very good. In those days, the way we looked at it, the stuff we had in our data center, we could control. It seemed like we were moving from high quality enterprise systems. We used like IBM P series and things like that in the data center, which was supposed to be very reliable. But this was cheap stuff, so it was going to be less reliable. So we had to be prepared for it to disappear on us. So that was one side of it. But the other thing is that we based our entire architecture on auto scaling. And this is something people don't seem to realize. The only thing we could put into production at that time was an autoscale group. Right? That was the only mechanism we had. So whatever you did, you built a machine image and you put it in an autoscale group. And if you think about autoscaling, scaling up is fine. You just add more machines. They come up, the traffic gets sent to them, everything's fine. If you scale down, how do you take machines out of the group? Well, what we did with the Chaos Monkey was just kill a machine every now and again, and the autoscale group would say, oh, there's one missing, and put it back. And that was really, we were testing the autoscaler's ability to put one back without disrupting customers. And that meant that the services, the code we were building was not, there was no unique content on any one machine. Right? It was always possible. There was no session state. Everything was retriable. So a customer request, if a customer request was being processed by a machine and that machine just disappeared, it would just retry somewhere further up and continue, and that you would be slightly slower, but everything would still work. So that was the model we wanted to have the developers work in, and that meant that we could scale down by not. You don't have to drain the traffic away from a machine and wait 15 minutes before you stop using it. You just turn it off. Right. So that meant that we needed to have that happening all the time around the system. So that was the idea. Think of the Chaos Monkey as a prerequisite for running autoscaled systems effectively. And that's the key thing. And then we went to, okay, we have 3 zones. What happens if we lose a zone? Well, we should be able to keep running, but we need to prove that. So we built a Chaos Gorilla that took out a zone. And then we started doing multi-region and what happens if we need to evacuate a region. So we started actively testing the ability to lose zones and regions. And I think that's still, it's kind of comparable to data center failover testing, but we were doing it much more frequently with much more automation than typical data center failovers. So I'd say Netflix is still, certainly what we were doing then was at the sort of bleeding edge of that. And most people don't work in that way. Most people have not baked in the ability to lose a zone or a region.
Excellent. So that actually led to many best practices and the whole stateless architecture. Today, particularly with the cloud native and Kubernetes, that is much more important. I think that architecture of separating the statefulness and stateless components and randomly killing stuff led to many best practices and a lot of architecture revolutions. So, switching gears, Adrian, from being a customer of AWS at Netflix, you became a leader at AWS, heading their open source strategy. So, when you actually did that, when you flipped the switch of becoming an insider and leading and heading their strategy, what was the biggest challenge that you faced?
Um, So going back a little bit, I dabbled with open source a little, but at Netflix we started an open source program that I led. So we were trying to open source the various pieces of code that Netflix had built, partly to encourage people to do things like us. So I had some experience trying to start and run an open source strategy, and had been going to some of the conferences, got to meet quite a few people that worked in open source. When I was joining AWS, I joined it for several reasons. One was, um, if you remember the AWS summits they have around the world, you've probably been to a few of them. They had 30 or so, 30 or 40 summits, and they were mostly being keynoted by Werner. And there's only
Right.
one Werner, and there were too many summits. So one of the things I was saying, like, I could keynote a summit, and they went, yeah, you probably could. Yeah, let's have you come in and we'll keynote. So I keynoted about 20 AWS summits in the time I was at AWS. And the first year I did about 10, and then they finally got more speakers in. So one of the things I joined was to just go out around the world speaking and trying to explain to customers and keynoting summits, which is an entertaining thing to be in. Yeah, have, I don't know, several thousand people out in the audience and run through the standard AWS story that is, they're all done roughly the same way. So that was one piece of really interesting experience I had. Then the other part was, okay, we have this problem because people don't like the way we do open source, right? And AWS's reputation was bad, and they had an internal team that made sure that they were doing open source legally. They were basically lawyers checking licenses and making sure that any code that was released open source was being done right. But that team was buried in engineering, had no marketing, no budget for going to conferences, nothing, right? They were a very minor member, sponsor of Apache Foundation, like some silver level or something like that. So they found a little bit of budget for one thing. That was really it. So I came in and said, okay, we need some people. I hired some people from outside the company that were well known in the open source community. We had some budget, so we started funding OSCON, All Things Open, FOSDEM, ultimately KubeCon, and Anil Gupta was one of the people I hired. He was said we should really join CNCF. So as we said, okay, let's just try that. So we wrote the documents and we argued our way all the way up to Andy Jassy and everybody else, and they said, okay, I think we convinced everybody that the CNCF had sort of been built as a club that was not supposed to have um, Microsoft and AWS join. Right, it was actually set up to be an alternative, and so then Microsoft and AWS joined, Azure and AWS joined, and it's okay. Well, now you can't complain about the people because they're here, right? So if you ever get in this situation where an industry consortium is being built to be against you in some sense, the best thing you can do is join it, and that neutralizes it. But it does mean that you then get to figure out how to adopt it. So it's somewhat painful for AWS to adopt Kubernetes, but it was better than the alternative. So this is a big strategic bet. My team justified that. It was probably the hardest thing we did. And then we ran the relationship. So I was on the board of CNCF. Anil took over when I moved on to some other things, and then he's changed companies, but he's still deeply involved in it. He's at Intel now.
Is it Anil
And
Gupta?
that, yeah, yeah. So
He was on my show too. Yeah.
yeah, I've known him for a long time. We used to meet at conferences and say, hey, we should work together sometime. It's one of those people, right? Anyway, and a bunch of other good people I had in that team. And eventually, David Nally still runs that team. I think he's the chairman of the Apache Foundation, which just happens to be work at AWS, but he runs that team. They've got the OSS team, awesome team. I think is the open source marketing team, and they still fund conferences and generally support what was going on. So part of it was the reputation. We just needed to turn up and be somebody you could talk to. And then the other thing that was to encourage AWS to open source more and make the open source launches better and help build out some of the teams that ended up doing sort of open source in the AI space in particular and around the Connect containers and Kubernetes and databases. Those are probably the three main areas where there was work happening. There was stuff happening that we weren't getting credit for. So we made sure that we created a Twitter account. and a blog and all these things, right? You have to have a channel, and we sort of regularly send things out. And it was just that was probably, we took, and I think we took the reputation of AWS from pretty negative to at least slightly positive. And then I moved on, and it's still, so external people would defend AWS in public over something that happened in open source. And there were various battles with startups that were in the open source space that were complaining about, started complaining about, well, AWS takes all our business and doesn't contribute to open source. And says, no, look, we are contributing. Look, see all this code we contributed. I say, yeah, but we don't like you contributing. It's like, well, you're complaining we weren't contributing. Now we're contributing, and you don't like that either. But we're contributing, and people would say, yeah, they are contributing. And so there were some fairly fractious sort of back and forth there. But so I did that for a while, and then I moved to the sustainability team around, again, there was a thing called OS Climate, which was another Linux Foundation project and by this time I'd figured out how to join Linux Foundation things. So I helped with the climate, the sustainability team join another open source related climate project. It might be worth looking at for people.
Cool, absolutely. So, as you mentioned, back in the day, AWS was criticized that they're only consuming open source and not contributing much. So, fast forward to 2023, as an outsider, what do you see as the big difference? What are the top open source projects that AWS is contributing to, and how did that perception change?
They have committers on some interesting projects like Redis. There's Postgres. There's better contributions back around MySQL. Some of these things over time, they'd basically built their own fork, right, internally, and then they were sort of trying to copy stuff from the public version back to the internal forked version. That gets increasingly expensive, and you get a bit more and more behind the public version, the open source version. So after a while, the economic incentive is, no, you really need to rebase back to contribute your weird fixes and changes back to the mainstream. And so that was part of what happened. So in most of the databases, there's good contributions back there in order to stay on the mainstream line, because customers want the most recent version. They don't want to wait a year or two until you finish backporting it to your internal strange thing that you've hacked up at. So I think that's just an economic incentive at scale. And then there's some interesting launches that were made around sort of container management, and there's a database. There's what's it called? SQL. If you want to add a SQL front end to a database, there's just a thing that AWS has used a bunch of times to do that. So that's another useful one. I forgot the name of the project, but it's getting
Is
to be
it
a few years.
Babel?
What was it called? Anyway, I have to go look it up. But there's, if you just visit the AWS open source page on GitHub, they feature the main
Right.
projects there. And I think, and they hired a bunch of people around Kubernetes, so etc.d committers and things like that. So there's places where they're seen as good players, committers. That's really what it takes. And internally at AWS, the management at AWS see open source contributions to strategic goals for teams. That's the other side of it, right? If it's like, no, your teams you should be working on features, don't contribute to open source, right? That's not productive. So you have to kind of say, no, this is important to the future of the service, so you have to contribute to it. And that was sort of an attitude change.
Right. So, as one of the key thought leaders in the industry, Adrian, I wanted to ask you about the promise of serverless computing. With containers replacing serverless computing, even Lambda is now literally running on top of containers. Did the container story steal the promise of serverless? And especially after Amazon Prime published that blog post about moving from serverless to monolith, there have been questions about the promise and the value of serverless. What's your view about that?
Well, let's put that blog post on one side, because I did a whole counter blog post on that. So let's put that on one side, because that's a different thing. It was mischaracterized a lot. I'm a big proponent of serverless. I think you can build something in days that would otherwise take you weeks. And I would always want to rapid prototype and build something quickly, even if I rebuild it again. And what I advocate is what I call serverless first. Like try to build the thing with serverless, and any piece that didn't work well in serverless, then go build containers for that. Like maybe you've got a persistent data store, or you've got some very intense, long-running job. Those are the things that tend to end up in containers. I know if do you know Dave Anderson, who wrote the book, the Value Flywheel Effect. You should get him on this podcast, because I've spent some time with him, and I him helped encourage him to write that book, wrote a forward for it. And that book talks about the speed at which you can get innovation done, if you have everything lined up the right way. Um, and it's a very interesting book. It talks about serverless, Wardley mapping, CDK patterns, all of these things, and a approach to innovation that is, I call it, ludicrously fast. That nobody thinks you can just roll out complete new products in a day. Like I thought of something, okay, well, let's put it up, and by tomorrow it's running. Like nobody does that. Well, there are people doing that, and he talks about some examples of people going at that kind of speed. Particularly with Liberty Mutual, which you think is a pretty old company. They would think up new insurance products and be test marketing them in days after they thought of them. So he's now working for an independent consulting company. So he's promoting his book. So you should go talk to him. And the book is Dave Anderson is the primary author. And so that's kind of where I think people should be looking. Yes, you need containers. So the containers were invented sort of in parallel to Lambda coming out. Lambda came out a little bit earlier,
Right.
and it's sort of addressing some of the same things, but it's got a very different model. Running serverless at scale, you need to be at huge volume to make it work effectively. Right? In order to have it be a product that makes sense, you have to be at very large scale. So AWS sort of priced it for when it would eventually be at scale. Right. So it was an incredible deal. It still is an incredible deal. You're getting capacity at, if it's very difficult to build a competitor to AWS Lambda without losing a lot of money for a long time, is kind of what I'm
Right.
saying. Because they priced it for where it would eventually be at scale. And you have to make it very efficient and at scale, and at very large scale, to have the economics work for it. So that's an interesting just aspect of one of the reasons serverless doesn't work in a data center, for example. If you
Right.
build a
Right.
little Lambda equivalent thing in the data center, and you look at the cost per call, it's like, this is ludicrous. We're spending way too much money on all the infrastructure to make you be able to fire up a function. But in the cloud, it works. So that's part of the interesting aspect of it. Um,
Absolutely.
yeah, and then and you can package. Really, the development pipeline is really where you can package a container to run as a Lambda function. So that's one thing, and then the way that Lambda functions are run as entire virtual machines, and you want to run a container as a VM. That was controversial to start with. Like a container was just run as a process, but it didn't give us enough isolation, certainly between customers. So you end up running, what's the
Bottle rocket.
Firecracker? Yeah, Bottle
Firecracker.
Rocket and Firecracker, right? So there was a couple of pretty significant open source projects, but what they give you is the ability to do a very lightweight virtual machine that you can wrap around your product, wrap around your system, and do it securely. So those technologies are like applicable to both Lambda and to containers as we get to more deployable components, basically. And then going to this blog post. The initial thing wasn't built serverless, it was built on step functions.
Right.
Right. And step functions, I think, and I actually say step functions first is actually a good approach. If you're doing a complex business logic sequence and you can model it out in step functions, it's actually the fastest way of building something. But again, if you run it too intensely at scale, you're going to run into the limitations. So what that blog post was actually about was taking a step functions based workload and moving it to a more integrated container-based thing, right? So the end result of that piece of work that was described in the blog post was a container. It wasn't a monolith. It was a container, which was one microservice in a large system, right? And if you look at the blog post, that container was invoked by a Lambda function.
Right.
So the final version, that what they were talking about, was a container invoked by a Lambda function. That's a serverless architecture, right? It was a Fargate container, which is serverless containers. So people saying this was somehow moving to monoliths or not doing serverless was just they didn't read the story.
Right.
And I wrote a long grumbly blog post, one of those things where you sit down and say the internet is wrong, I'm going to correct it, and wrote everything about it. Was I think it was called So Many Bad Takes was in the title of my blog post. You can probably find that. But yeah, so the end game here was they did a serverless first thing for doing some experimentation. They were running it on a proportion of their workload. Tommy said, we really need to run this on every live stream that Prime does, because they were doing more and more live. And when they tried to run it on every live stream, they ran into some issues. So they rebuilt the thing to be a serverless microservice based on Fargate rather than based on step functions. And that was all they were. The blog post was up, and then I think DHH picked it up and had a rant about monoliths, and was like, okay, didn't really read the story properly. Anyway, so that's my kind of counter rant on that topic.
Yeah. No, that was very insightful. So basically, the key takeaway, Adrian, is start with serverless, and wherever you're not able to fulfill that stateless per invocation based approach, switch to containers. I think that's the key takeaway.
Mhm. Yeah, and I think that will get you something done faster. And my joke here is that if you're looking at Kubernetes, you'll spend more time arguing about which version of Kubernetes to use than it would take to build your entire application serverless. There's something about having a constrained architecture pattern that says there's only one way to do this. My decisions have already been made. We don't have a discussion, we just start building in this model. So it actually, there's this sort of tyranny of choice thing. If you give people too many choices, yeah, that looks good, but it means they'll do slower development because they keep trying to choose things, and maybe they change their mind and they keep trying different choices. And you end up thrashing a lot more and making slower progress than if you just say, now, my problem I'm trying to solve is some business problem. And I have an architecture I know well that constrains me. And if it'll fit, if I can do it in that constrained way, that's probably the fastest way of doing it. And then you kind of just identify where your architectural model is not meeting what you need, and then you go, okay, let's try something different there.
Finally, your last role at AWS was leading the sustainability effort. Now, why is sustainability important for the industry, and why is it often overlooked? And what is the industry in general doing about sustainability?
There's a lot going on. The cloud providers for quite a long time have been moving to generate more sustainable electricity. And there's a couple of reasons for that. One, it's the right thing to do, but it also turns out it's the cheapest electricity. If you want to buy gigawatts of power and you go to your local power supplier and you say, okay, this is how much it's going to cost on, so many cents per kilowatt hour or whatever. And they go like, I can put up a wind farm or a solar farm or a battery array for less. So it's not just, people doing I want to be green. It's actually economically being driven that the biggest users of electricity have an economic incentive to use the cheapest electricity sources, and those are now, and have been for quite a while, the sustainable ones. So given that, AWS now has over 20 gigawatts of power around the world, and they're very much around the world. So more recent years, they have it in Australia, in Japan, in India, in China. They actually have, you can go see on their website, large-scale solar and wind projects, and increasingly battery tied to those. If you look at Azure and Google, they're strong in terms of similar projects in Europe and the US, but they have very few projects in Asia. So AWS is a little bit ahead in terms of rolling out sustainable power. And then based on the fact that they can generate so much renewable energy, the current situation for AWS is that certainly the Chinese and Indian regions for AWS, they say 100% green because we generate as much energy as we use on an annual basis. You have to say there's an annual basis. So on a day-to-day basis, they may be using a bit of dirty energy, so it doesn't actually cause a zero over the year, but this is sort of the difference between net zero and absolute zero. Like the net zero means that they are generating as much energy as they use for the year. So there are times where they're generating extra green energy that they're not using, that is just going into the grid, and other businesses are getting the benefits of greener sources. So it's sort of, if you look at it from that point of view, some other industry is saving some carbon at times to make it all match out. So these things is where it gets confusing, and why this stuff is like people have different opinions anyway. So that's but the key thing though is that it's something that the cloud industry is leading the world in the speed at which it is moving to green energy. It's one of the cleanest industries and one of the fastest to go through this transition. Lots of other industries are following along, but it's been very aggressive overall.
So do you think an entire AZ of an AWS region can be powered by the clean energy sources like solar and wind?
Yeah, yeah, that's what they're doing. Yeah,
Wow.
they're putting in hundreds of megawatts of, a typical solar array will be a few hundred megawatts. A wind array will be a few hundred megawatts. Um, and then they're sourcing green energy from other places where they can buy it as well, from other fun places which they didn't build themselves. Again, if you go to the AWS website, or actually Google, or I did a talk recently, and I posted the slides to I put my slides on GitHub. If you GitHub Adrian CO/slides, you look for the
Sure.
newest thing there. You'll find my cloud provider green energy update. I did this recently for a CNCF meeting a few weeks ago, or last week. Um, I've got screenshots in there of the different cloud providers with URLs, so you can go click through and see what they're currently doing. So that's what's going on from an energy production point of view. And then you look at what customers want. Why is this happening, as well as it being economically the right thing to do? We're seeing individual requirements coming through the supply chain, where Amazon is now requiring every supplier of Amazon to disclose its carbon footprint. That came in last year. Apple has the same thing. All the big consumers of technology and resources are saying, no, you need to tell us what you're doing. And that's being driven by governments around the world saying, okay, you have to disclose your carbon footprint, also the climate risk, which is a little subtly different thing. But what's the risk of carbon of climate change to your business is one of the other things that need to be modeled. But fundamentally, how much carbon are you putting out there needs to be reported. For California just put laws on the books. They were approved by the governor a few weeks ago or a month ago. The EU's had a rule that's been in place for quite a while, and you have to report to that. The UK, New Zealand, other countries around the world are at different stages. So if you operate globally, you're going to have to report your carbon footprint. And so then to figure out how do you do that? Well, most of the carbon footprint comes from physical things you do. If you think about atoms and electrons, if you have any idea of physics, that atoms are way, way heavier than electrons. If you move atoms around the world, that consumes a huge amount of energy. Moving electrons around the world consumes very little in comparison. So pure digital businesses have a pretty small carbon footprint. And by just sourcing green energy, you find that most of your carbon footprint, if you're a bank or a SaaS provider, will be your employees commuting to work, buildings, your office buildings. That will be almost everything you do. The computers are pretty easy to zero out. But if you are in mining or transportation, most of Amazon's carbon footprint is in transportation. It's this huge delivery business and manufacturing. It's a few percent of Amazon's carbon footprint is AWS. Yeah, it is energy basically. It's 2.9 million out of 70 million tons, I seem to remember, something like that,
Wow.
for the electric carbon footprint, electricity versus everything. So most of Amazon is burning diesel fuel for aircraft and trucks. And they now have 10,000 electric delivery vans from Rivian running. They announced that last week. So they're gradually trying to roll out electric delivery trucks. That's how you decarbonize a business. So if you look at the businesses you're in, if you're in some physical business, like manufacturing, you have to figure out or how do I use green steel, green concrete for all your buildings, or all your how do you have low carbon in your entire supply chain? Um, Amazon started building data centers with low carbon concrete. There was a story about that last week as well, in the last few weeks. So this is all, you have to go through your whole business and figure out how to decarbonize it. And this is being driven, I say, by regulations, but also by employee activism. People don't want to work for companies that are going to destroy the future, basically.
Mm.
Particularly if you have sort of the classic thing is, teenage kids come home from school and say, "Hey, parent, what are you doing to save the world that I'm going to grow up in?" And don't underestimate that has a massive impact on people. Yeah, what are you doing? Well, I'm working for a company that's destroying the world. Is not a good answer, right? So you have to kind of look at what are you doing, and you want to work in places and invest in places that are building a renewable future.
Excellent. Very insightful, Adrian. So that brings us to the end of this discussion. Thank you so much. It's been very, very valuable and insightful. And thanks for all the great contributions you made to the community and the ecosystem. They are helping a lot of customers and a lot of cloud adopters. So I look forward to talking to you again. Thanks once again for joining my show, and have a great day ahead.
Yeah, thank you very much.